All right, today we're working with special right triangles. All right, we're going to find other ways to solve for missing sides of a triangle. So far we've used our Pythagorean theorem to find a missing side of a right triangle, whether it be the leg or the hypotenuse. All right, but with special right triangles, we can find two missing sides. Okay, so before we had to have two of the side lengths, and we can use the Pythagorean theorem to find the third. But now we can actually go ahead and find missing side lengths when we know just one of the sides. Okay, so two of them are missing. All right, so there are two special right triangles that we are going to talk about. The 45-degree, 45-degree, 90-degree triangle, and then the 30-degree, 60-degree, 90-degree triangle. A couple things to notice. One, they both have a 90-degree angle in it because we are still talking about right triangles. The second thing to notice that in both of these, they add up to 180 because all three angles in a triangle have to add to 180. So we're obviously sticking to that fact. Okay, so let's talk 45, 45, 90 first. It tells us that all triangles whose angles are 45 degree, 45 degree, 90 degree are similar to each other, so the corresponding sides will be proportional. Okay, they will be similar because of that whole angle-angle concept. We can prove them similar because at least two of the angles are congruent. All right, now there's two pieces of information that you need to memorize here, and then we'll get into what that is. But if you notice, it says memorize this information. That means that you remember it. Okay, so the 45, 45, 90 degree triangle theorem. In a 45, 45, 90 triangle, both legs are congruent, and the length of the hypotenuse is square root 2 times the length of a leg. Okay, take a look at this diagram. So the legs are the ones that are opposite the 45-degree angles. Sorry. Opposite the 45-degree angles. Okay, and they are congruent, meaning they're the same size. So if I told you this one was 6, this leg would be 6 also. Okay, so in a 45, 45, they're congruent. And if you think about it, it makes sense because think to yourself for a second, if these two are both 45, what type of triangle is this going to be? It's going to be an isosceles because the two base angles are congruent, so therefore those two sides would be congruent as well. So of course it's all linking together and making sense now. Okay, so the two sides are the same length, and the hypotenuse is going to be whatever that side length is times the square root of 2. So once again, if I told you the legs were 6, that would make the hypotenuse 6 radical 2. Okay, just a little bit bigger than your sides. Okay, so the hypotenuse equals the square root of 2 times whatever the length of the leg is. 6, negative 10, well, not negative 10, but 6, 5, 5.426, whatever. Okay, it's going to be times the square root of 2. So if we know that the leg is equal to 10, then our hypotenuse is 10 times the square root of 2. Okay, we always like to put the number in front of the radical. Okay, just so we don't get confused on what's underneath and what is not. All right, so if this makes sense to you and you're able to visualize a triangle and solve for missing side lengths, then go ahead and do that. All right, and I'm going to talk your way through it, and then I'm going to show you another method that some of you may prefer. So let's find the length of the hypotenuse. So in the problem it says, what is the length of the hypotenuse of a 45, 45, 90 triangle with a leg length of 5 radical 3? Well, I can actually go ahead and do this one without a diagram, but it's always good to draw one. But for those of you that are forward thinkers, let's think about this. The leg, I found purple by the way, I'm excited. The leg is going to be less than the hypotenuse. The hypotenuse is going to be whatever the leg is times radical 2. Well, the leg is 5 radical 3, so it's going to be 5 radical 3 times the radical 2. Okay, because the hypotenuse is the leg times radical 2. So when I multiply, thinking back to your Algebra 1 skills, I times the numbers under the radical, and I times the numbers in front. Well, the number in front here is just 1. Okay, so 5 times 1 is 5. And then radical 3 times radical 2, 3 times 2 is 6. So this is my answer. Okay, so I went ahead and I did the leg times the radical 2 to give me the length of the hypotenuse. Okay, so some of you can think like that. Okay, you could have drawn a diagram, 90, 45, 45. So therefore the leg is 5 radical 3, 5 radical 3. So this one has to be the 5 radical 3 times radical 2, just to get a visual. Okay, let's use another method for those of you that are going to have trouble visualizing or you're not quite sure what we're doing with. We're going to set up a proportion because we're all pros of proportions. This little diagram over here, okay, this little diagram you need to remember. Important, important. And yes, I found yellow. All right, now the information that's on there is going to use us to help us set up a proportion. We are going to fill in the parts. So if I'm taking a look at my diagram, go ahead and draw a quick triangle again. 90. Here's my 45 and my 45. Okay, and I see that I have, going back to my problem, so we're still doing the same problem. My legs are 5 radical 3. Okay, so across from my 45-degree angle is a 5 radical 3. Across from this 45-degree angle is 5 radical 3. Across from the 90, we don't know, so I'm going to put an X for right now. That's what I'm trying to find. So now I'm just going to fill in the chart. Okay, so across from my 45-degree angle, I had a 5 radical 3. Across from my 45-degree angle, I had 5 radical 3. Across from the 90-degree angle, I have X. So I'm just filling in those side lengths, okay? Really the lengths of the legs, the length of the hypotenuse, which I don't know now. Yes, we know the answer already, but you know where I'm going. So from here on out, I'm not going to use this. I'm going to use this information on the bottom, and I'm going to set up a proportion. Sorry. All right, I only need 2 of them. So I will use these 2 and set up a proportion. And it doesn't matter. Of course, you're going to use the one with a variable. Okay, and the other 2 are the same. So 1 over 5 radical 3 equals radical 2 over x. So I'm just setting a proportion, and now I'm going to cross multiply to solve for x. 1 times x is x. And then I have 5 radical 3 times radical 2, which we already did the math. That is 5 radical 6. And that's my answer. Okay, so if it helps you, if you're having trouble visualizing on the triangle, you can set up the proportion to solve. All right, so let's use both those concepts here. So the problem says the length of the hypotenuse of a 45, 45, 90 triangle is 10. What is the length of one leg? Okay, no matter what, we are going to start by drawing a triangle. Okay. I have 90, I have 45, and I have 45. The problem tells me that the length of the hypotenuse is 10. So here's method number 1. If that's 10, we don't know these 2 sides, but these 2 sides are equal because that's the characteristic. So what I do know is this. I know that the leg, x, times radical 2 is equal to the hypotenuse. So now I'm just going to simplify it. I'm going to solve it because the leg times radical 2 equals the hypotenuse. Hypotenuse is 10. So in order to solve this, I have to divide both sides by radical 2. Okay, now here for a second, think. I cannot leave a radical in my denominator. So what I need to do is I need to do something that's called rationalizing the denominator. It's going to get rid of that radical for me. In order to do that, what I'm going to do is I'm going to multiply by my denominator. So I'm going to go ahead and multiply by radical 2 over radical 2. Okay, because whenever you change a fraction, whatever you do to one part, you have to do to the other. So if I'm changing my denominator, I have to change the numerator too. All right, so 10 radical 2 is just 10 radical 2. Okay, because I would multiply my coefficients, my 10 and my 1, and I multiply the numbers under the radical, and this guy doesn't have one. Right down here, radical 2 times radical 2 is the square root of 4, because 2 times 2 is 4. And guys, what's the square root of 4? It's 2. Oh, it's 2. Good. Okay. Anytime you multiply a number under radical by the same exact thing, the radical just cancels itself out, and you're left with that number. And then the very final thing I would do is reduce. Okay. 10 divided by 2 is 5, so my answer is actually 5 radical 2. Now, if the directions do not tell you to rationalize the denominator, you can leave it like this, okay? It'll be our little secret. But if they do say rationalize the denominator, you have to go through that process, okay? Or if they say leave it in a decimal form, type it into your calculator and get that answer. Okay, so method number one was drawing your diagram and remembering that you can just multiply the leg length, which was x, by radical 2 and set it equal to the hypotenuse. If that was a little too much for you, let's go ahead and talk through our other method. Let's set up that chart. So you will need to remember this chart in order to be able to make it work. 45, 45, 90. 1, 1, radical 2. Okay, the 1 and the 1 represent the length of each leg. The radical 2 represents the hypotenuse because it is radical 2 times the length of the leg. Okay, so let's fill her in. We don't know the leg yet. That's our x. The hypotenuse is 10. All right, so once again, I'm going to set up a proportion. Doesn't matter which one I use, the variable is the same. So I have 1 over x equals radical 2 over 10. I cross multiply and I get x radical 2 equals 1 times 10, which is 10. And then from here on out, my work would be the same as we did up top here, okay? Just a different way of getting to our answer. So if you need to set up the chart and then write the proportion, go ahead and do that. Okay, because in this problem, you're given the hypotenuse, so some of you may have trouble thinking backwards and thinking about where to put that radical 2 in an equation. So if the proportion helps, go ahead and do it. All right, ladies and gentlemen, I'm going to go ahead and I'm going to pause the video, and I want you to try problem 3 on your own. All right, I'm going to do it too. I'll do it both ways. I'll show it first just by an equation, and I'll show it with a proportion. So go ahead, pause the video, and I'm pausing it as well. Okay, before I go over, I just want to point out that I found this really neat feature where I can choose any color I want to write in, and I'm really excited. Okay, moving on. So I have it shown 2 different ways. Method number 1, for those of you that are ready for it, is honestly just knowing the rule. Knowing that the hypotenuse is the leg times radical 2. So since you were given the leg here is 100, it's just 100 times radical 2. So if you remember that fact and that's easy for you to see, you can get right to your answer. It's actually less work, but you have to remember the hypotenuse is the leg times radical 2. If you weren't sure, you could have used the diagram. 45, 45, 90, 1, 1, radical 2. Fill in the missing pieces, okay? So across from the 45-degree angles, I have 100s. So that goes below them in my diagram. Across from the 90-degree angle, for right now, I have my x because I don't know it. All right, and then I set up a proportion. 1 over 100 equals radical 2 over x, and I solve by cross multiplying. 1 times x is x. 100 times radical 2 is 100 times radical 2. You can leave it like that. All right, if you're having troubles, make sure you are writing questions down and you're bringing them to class. Don't come in with the excuse of, oh, well, I couldn't ask the computer a question. No, you can't, but you can write down your question, ask in class. This isn't going to work for you if you're not being an active learner, meaning you are asking questions. All right, so the other special triangle we're going to talk about is the 30, 60, 90. It also has a set of numbers and rules. This one is a little different. The other one was nice because 2 of the legs were the same. Okay, so in a 30, 60, 90, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is radical 3 times the length of the shorter leg. Okay, so for this one, a lot of you may find it easier to use this chart down here, but we'll talk about it. So take a look. If this is my shortest side, now remember, the shortest side is going to be across from the shortest angle. That's just the way it is. The second shortest side, or the second longest side, is across from the middle angle, and the longest side is always across from the biggest angle. And since we're doing right angles, it's across from the 90-degree angle. Okay, so I have my S, my 2S, and my S radical 3. So if I told you that this side length down here was 3, that means that this one's 2 times 3, which is 6, and this one is 3 radical 3. All right, that's not hard to do, but if you're given one of the others, you've got to work backwards, and that's where it gets tricky for people. So the proportions may help you. Okay, so the hypotenuse equals 2 times the shorter leg. The longer leg equals radical 3 times the shorter leg. Okay. Or we can use the proportions to help us, and here's your basic thing. So memorize this. Memorize the 2 little graph charts, and you'll be good to go. So let's solve the problem. What is the value of f in simplest radical form? Okay, now, first of all, let's walk through the proportion method, and then I will show the other method. So let's set up our proportion chart. So this time I got 30, 60, 90. Then down here I have 1, radical 3, and 2. Okay, because the 1 represents the shortest side. The 60 means I multiply the shortest side by radical 3, and across from the 90 I multiply it by radical 2. All right, let's fill in our missing pieces now. Okay, so across from the shortest side, looking at your diagram, here's the shortest angle, so that means that one is the shortest side because it's across from the shortest angle. Peel. Okay, so this is 5 radical 3 over 3. Across from the 60-degree angle is this guy. It's 5. And across from the 90-degree angle is my variable, so that's the one I'm solving for. My f or my x or whatever you want to use. So now I'm going to set up a proportion. And it doesn't matter which ones you use. I know I need the 2 over f in there because that's my variable. So it doesn't matter if I set it equal to this or if I set it equal to this one. It doesn't matter. I'm going to do the radical 3 over 5 just because it looks less threatening. I don't have a fraction in a fraction. And now I cross multiply to solve. I have f times radical 5. 2 times 3 is 6. So to solve for f, I have to divide by radical 5. Okay, and once again, if the directions do not say you need to rationalize your denominator, you could go ahead and leave it like that for now. No problemo. If you're asked to rationalize the denominator, we have to multiply by the square root of 5 over the square root of 5, which gives me 6 times the square root of 5. And we looked at this earlier. 5 times 5 is 25, and the square root of that is 5. Okay, and I can't reduce 6 and 5, so I'm done. All right, so that's using my proportion method. If you're comfortable with that, then just skip ahead to the next part. If you want to take a look at how you would do it without the proportions, you're more than welcome to listen along as I go through that. Okay, so without the proportions, I need to know my values. I need to know that the longest side or the longest leg is radical 3 times the shortest leg, and the hypotenuse is 2 times the shortest leg. So my directions ask me to find the length of the hypotenuse. So the hypotenuse is going to be 2 times the shortest leg. Okay, I'm going to use that information. Well, the shortest leg is this, so it's going to be 2 times that. So to multiply, 2 over 1,